Hey everybody, hope you're all having an amazing day, and I have a great video for you today. In today's video, I will show you how to get YOLO v3 up and running on your local machine so that you can start to perform amazing object detections such as these. By the end of the video, you'll be able to run these detections yourself and have a better understanding of how YOLO v3 works and how to play around with it. I'll be showing you the best ways to get YOLO v3 for both Linux and Windows machines, so I got you covered on both bases. And I'll also be showing you how to enable GPU so that you can perform these object detections on both images and video in real time and get detection results back in milliseconds. So let's get right into this video. So first things first, we need to get our hands on the code. And so the way the YOLO v3 works is it works on top of a framework called Darknet, which gives it the capabilities it needs to be able to run the object detections. So the repo we're going to use is YOLOv3's version of Darknet. So the original version of Darknet by Joseph Redman doesn't really support Windows very well, or at all really. But YOLOv3 has kindly gone through editing and optimizing Darknet for Windows as well. So this repo works amazing for Windows and Linux. So that's why we're going to go ahead and click on the clone or download, copy the link, and we're going to go ahead and clone the code. If you don't have Git installed, then of course you can just download the code as a zip and extract it to a folder. So I'm just going to go ahead and clone it, open up a command prompt or shell, git clone, and paste that in there, and it'll create the repository for you. I'm just going to show you guys where I'm doing this. So I'm just doing it straight on my C drive in a repos folder, and then there's Darknet. So as we can see, it has properly cloned the code. So now we can move on to the next step. So if we scroll down in YOLOv3's repo to his README and look at the requirements, that's really what the next step is. So you can decide whether you want to enable CUDA or OPENCV to be used with your YOLO v3. Both of them help optimize, so I recommend using both. GPU, CUDA, allows you to accelerate the processing, so detections, instead of taking over 10 seconds, will take under 100 milliseconds, which is crazy, about 100 times faster. And then as well, OPENCV allows it so that you can see your object detections in real time instead of having it to save it to a file and then opening the file and seeing your detections on the image. So they both help greatly, and I recommend trying to get both up and running, and that's what we'll do next. So firstly, you're going to want to see it if your computer has a GPU. So you're going to go to Device Manager, open it up, and go to Display Adapters right here. And if you have an NVIDIA GeForce or some type of NVIDIA name driver, then that means that you have a GPU on your machine. So I have the GeForce GTX 1650 GPU. So next things next, you're going to want to go to Google and just look up CUDA, and then you're going to want to go to CUDA Wikipedia. So CUDA is what you have to install with your driver in order to get things to work properly. So you're going to scroll down and you're just going to look at the toolkits. So you're going to go and find your NVIDIA driver on this list. The newest versions are at the bottom. So I had a 1650 or 1660, so they're both under the Turing model 7.5. And I can see that the Turing model means that I should be getting the CUDA SDK 10.0, which is the latest version. So if you found your CUDA version and you now know what version you need, you're going to want to go to CUDA download, just Google CUDA download, and then click the first link. So this is automatically going to go to the latest version of the CUDA toolkit. If you need an older version, you're going to want to go to the legacy releases and find the version of your choice. I actually have 10.1 downloaded. But if you go back, you can either choose the Windows or Linux version, the version of whatever operating system you're going to want. And once you've downloaded it, you're going to want to click on documentation and follow these steps, the install guides for Windows or Linux, whichever version you're on, and follow those all the way through. And now we can move on to the next step, which is OPENCV. So as I said before, OPENCV allows you to view your object detections right away in real time as you're running the program. and not have to save it to a file first and then open it. So I recommend downloading OPENCV. It can also help increase the detection time. I'm actually going to refer back to my previous video on my channel where I showed how to download and install OPENCV from source. So that's what you're going to want to go ahead and check out my video if you don't have OPENCV downloaded. It'll show you the steps, but you're going to want to tweak one thing. When you're building from source using CMake, you're going to want to scroll down, and if you have CUDA, if you've just downloaded CUDA and have the toolkit installed, you're going to want to click this with CUDA box and check the with CUDA box and then configure and generate the code. This will enable your GPU with OPENCV and allow us to get that optimal performance when running YOLOv3. Another tip when you're building OPENCV from source and enabling with CUDA, once you've configured once, you're going to see this CUDA archbin property come up, and it's going to have all these different versions. But you're going to want to refer back to the CUDA Wikipedia that I showed you earlier, and based on your driver and your GPU, you're going to want to check the version on the left side and see which one you are, because if you're a 7.5 like I am, or even a 6 or something, you don't need all those previous versions. And what OPENCV will try to do is it'll build the architecture for all these versions. So if you have like a 7.5 like I do, you're just going to want to go and get rid of everything below 7. Or if you're a 6 something, you're going to get everything below 6. And then generating the code from this will only build those architectures that you know you have, and it'll help the build time of OPENCV with CUDA drastically decrease. So that's kind of a best practice I recommend for you guys. So now we can get back to actual Darknet code. So we're going to open up where we put the code, Darknet, and we're going to look for the build folder. So right now this only has one folder in it. So we're actually going to want to build Darknet from source now using CMake, and that'll generate the executables that we need and the solution folders we need to get YOLOv3, the last little piece of it, together and running. So now that we have all the requirements and dependencies downloaded and installed, we're going to go ahead and go over to the official YOLOv3 site. So this YOLOv3 site is by the creator of YOLO. You only look once, and his name was Joseph Redmond. So he actually has a demo if you want to see a cool video of him using YOLOv3, and he explains the process and everything he did. And he shows you actually how it works, but he only did it for Linux. So if you're on Linux, I recommend you now come over here. And so he gives the steps of how to actually run YOLOv3 with Linux. And on Linux, if you're on Linux, you're fortunate enough because it's extremely easy on Linux. For those of you on Windows, such as like myself, it's a little bit harder, and we're going to get into that. But if you're on Linux, all you have to do is do the command make, and then you also have to grab the weights. So you guys can do this wget command and download the weights. So if you're on Linux, go ahead and run this command and get the weight files, the weight file that has all the weights for the layers of the YOLO architecture. So that'll allow you to run your detections. And we can actually grab it now even if we're on Windows. So I recommend just downloading it by clicking this button. And it's going to go ahead and download. And once it's downloaded, you're going to just want to copy it over to the root directory of our Darknet project. So I'm going to wait for that to download, and then I'll copy it over. So once our weights file is done downloading, we're going to go ahead and move it over from our downloads folder into our home folder of our Darknet. So we're just going to go ahead and drag it to copy it over. Perfect. Now it's in our Darknet. And now we can go back to the website, the YOLOv3 official website. And so you can see that for Linux, the command is make. So we're going to go ahead and look at the make file that helps to generate when you run make. So we're going to just right click and open it with our notepad or any text editor, anything like that. So as you can see off the bat, there are all these parameters at the start. So this is where you set whether or not you want the make file to make Darknet with GPU or with OPENCV. So by default, it's going to do none of those. But if you went ahead and installed CUDA and stuff like that, then you're going to want to go ahead and put a 1, so that will run it with GPU. And if you have your GPU, you're also going to want to do CUDA. But I would recommend not doing the half to start. The half can add to a lot of complications, so I would leave that as a 0 and off. And then if you did OpenCV and built OpenCV from source, you can go ahead and put OpenCV as a 1, and then you'll just save that, close it, and then from your command terminal, you're going to go ahead and run the make file by the command make, and then you can actually go ahead and do your detections right away. So for Linux, it's that simple, and this is the command you're going to want to copy in and run. And if you see an image with a dog, a bike, and a truck pop up, then you've successfully done it. And it's that easy with Linux, so if you're on Linux, you're fortunate enough. But if you're on Windows, now is when I'll get into how I did it on my machine. Extremely fast and the best practices for doing it. So let's get into that. So if you're on Windows and you've just downloaded the weights file as I showed you, you're going to want to go ahead and open up CMake, and you're going to put in as the source code just the root directory of Darknet, and then for your build directory, you're just going to go into the root directory and go to the build folder. So that's it, and then you're going to go ahead and click configure, set it to whatever architecture you're on. I'm a x64-bit machine, and click finish, and then you're going to go ahead and that's going to start configuring, and we'll come back when it's done configuring and show you the modifications to the parameters that you need to perform in order to either get GPU or OpenCV to be built with the source code. So when it's done configuring, as usual, everything's going to pop up in red. To tell whether or not your GPU has worked properly, you should see that your CMake CUDA compiler shows CUDA and the version that you downloaded. And for the rest of this, we're going to go down and scroll down, down. And we're going to look at the enable CUDA. So if you have CUDA and you downloaded your GPU, NVIDIA CUDA, you're going to want to go ahead and click enable CUDA and enable CUDA. But I prefer, like I said, for Linux, I prefer not doing the CUDA half. So I'm going to go ahead and unclick that one. I find I actually get faster results when I disable that. And then the next one is OpenCV. If you've gone ahead and built OpenCV from source and you have it working, then you're going to want to go in and enable OpenCV as well. And now that's it. You should have all of your GPU and CUDA files should automatically link. So now we can go ahead and configure again, and hopefully this time we don't get any red fields, and then we can generate. So we can see, perfect, we don't have any red fields, so that means we're good to go ahead and generate the code. So we're going to go ahead and click generate. It's super quick. It's done. And if we head back now to our root directory of our Darknet and in build, we're going to see that we have a lot more. And we have a Darknet solution folder. So we're going to go ahead and open that with Visual Studio. And this is where we can actually build the code and then after that install it and have our final test to see whether or not we have successfully gotten YOLOv3 with Darknet downloaded and installed. So you're going to want to go ahead and change the version to release. This just optimizes it. And then you're going to right click on all build and go to build. So we're going to let this run, and then I'll come back and show you what the next step is. So hopefully if all goes well, fingers crossed, you'll see that you'll get your build all succeeded, none failed. Some common errors that I see here are that the .lib, like it's missing an OpenCV. It can't find an OpenCV.lib file. And if that's the case, you'll probably have to open up your folder for OpenCV. And I find that if you go into OpenCV, build, install, whichever compiler you used, and then the VC16, and the lib is where you'll find all the .libs that are attached with your OpenCV build. And remember, this is in your OpenCV, wherever you built OpenCV from. And then you're going to want to just right-click on whatever project it was that had the error, go to Properties, and then go to Linker, and add it here to your additional libraries. And that will usually fix it. If that doesn't fix it, and it's not a linker issue, then you can add it to your additional include directory right up here. And if it's a different file, like not a .lib, and it's a .cpp or HPP, just look in the OPENCV folder for wherever that file is and add that file path to the linker or the C++ directories. So once your build is complete, you're going to want to go and right click over install, and then now you're going to build the install, and this will create the Darknet executable that will allow us to do our YOLOv3 detections. So we're just going to build this. This one should be pretty quick. Perfect, one succeeded, 6 up to date, because it did not rebuild the other projects, just the install itself. So one succeeded. So now we can actually run our detections. So if you go back to your Darknet root folder, you should now see that there is a Darknet application file. So this is our darknet.exe that we can executable that we can run and now do our detections with. So we are going to open up a command prompt or a shell, and now we can run this test command to see whether we have correctly installed Darknet with YOLO. So we're going to do, for us, since we're on Windows, we do exe, not just the /darknet, detect, and the first parameter is the config file. So this is where the default YOLO config file gets placed in the config directory. And then this is wherever you downloaded the YOLOv3 weights to earlier. So put those in, and then data folder is where there's a bunch of examples of images you can run the classifier on. So this is just a picture of a dog with a bicycle and a truck. So we're going to go ahead and run this. And looks like it's working. This is through all the convolutional layers. And if you have OPENCV enabled, this will pop up right away where you can see the detections. And so it's saved to predictions.png. So if you just open up the folder and let's see if we can find it. Predictions. Oh, it's a JPEG. And we'll bring that in. And you can see that it has run the YOLOv3 detection and has found a dog, a bicycle, and a truck. And if you actually go back to your command prompt, it will give you the accuracy values. So the bicycle was 99% accurate, 100% accurate was the dog, and the truck was 94, as well as with the time that it took. So it took 87 milliseconds. So you can see how fast that is. It's real time detecting it right away. And if you did not have GPU enabled, that would be anywhere between like 7 to 11 seconds. But with GPU, you can see that it's down to milliseconds, which is incredible. So now you can go around and pretty much change this data.dog/dog.jpg to any picture you want to detect on right now. And so the detect command is actually a short form of a longer command that is being done. So it's right here. Detector test is the long one. Detector test where the config, the data, the config YOLO architecture, the weights, and the dog. So you can see that by default, it actually loads in the COCO data set. So this has about 80 labeled classes that you can distinguish between. So you can see in our past example that bicycle, dog, and truck are within the COCO pre-trained model. And there's a bunch of other things. If you want to check out what all can be detected using the COCO classifier, just Google COCO dataset images, and it'll show you all the classes and all the different types of things you can detect using the pre-trained COCO model. So I'm going to show you guys just what the YOLOv3 config file actually looks like. So if I go ahead and go to my config file, go to find the YOLOv3. Here it is, and we're just going to right click and edit it in Notepad. So you can see that it's set to testing, which is perfect because that's what we're doing. We're just testing the detector, and it's just going to do it once. But if you're going to train, you can actually train your own custom model, which I will actually show in a future video. And this is kind of the architecture that shows all the different convolutional layers that the YOLOv3 architecture has. And then there's also YOLO layers within here. So they're all preset. I wouldn't mess around with them too much unless you're trying to become an expert with YOLO v3. And I'll show you how to mess around with them for custom detection, like I said, in a future video. So let me know down below if you want to see that video. So hopefully that'll make me get it done faster. But yeah, so it's set to testing on one image automatically. So that's what you want for your classifier. There's a bunch of other models like tiny.config, which is a lot smaller for your memory. So you can use it on more portable devices if you need. Like you could actually have it on a phone or a camera. Yeah, but you can. I'm urge you to play around with all these different types of configs. Just Google them and look them up. But YOLOv3.config is the standard pre-trained that works with the COCO dataset that you just pointed it to. So I think that's pretty much it. I'll just show you guys a couple more examples and how you can actually do it with video. But what you're gonna actually want to do if you're looking to see all of the functionality that you can do and all the different commands, I urge you to go back to the beginning where we went to Alexi AB's Darknet. His README will explain to you guys a little bit more in depth what you can do and certain commands you can run in order to either suppress certain things or hide certain things. So now I'm going to show you guys how to use the YOLOv3 object detection on a video. So it's pretty similar to this last command. It's going to start with ./darknet detector. Instead of test, it's now demo. And then you're going to do the same stuff, same parameters. So you point it at the COCO pre-trained data, your YOLOv3 config, the YOLOv3 weights. But now you do the flag external output. So this will show you the object detection happening in real time. And then you point to the video. So I have this video I put in this test folder. You can use any video here, like a video of yourself, just you walking on the street. That's what you'll see in this video. It's somebody walking the street in Asia. And then this flag out_file name. It'll actually save the YOLOv3 object detection overlaid on the video so that you can watch it back and see how it did. And then this results.avi just saves it as the results.avi file. But you can call that anything you want. So if we run this, if we run it, you'll see it'll load in the architecture. It's all the weights and layers. And then as you can see, it's running it as frames. So it's going about 12 frames per second. It slows down, but you can see that it's detecting people, car, bicycle, backpack, and in real time. So you'll see that when we actually get this saved to our results.avi file and play it back, it'll be at full speed. But the YOLOv3 slows it down slightly so that it has time to do the detections. So you'll see that once it actually finishes and we open it up, the results.avi, it will be in full speed and less blurry. This is just a way for YOLO to do it easier. So as it finishes up, we'll get to see the video outputted with the overlay on top at full speed. So now that the video detection is done, we open up our folder, and now we can just look for our results.avi file. So here it is. We open it up, and you can see that it's actually in real time, as if it was just doing the detection on someone's phone walking down the street, which is pretty cool. It's pretty amazing what YOLOv3 can do. So you can play around and use your own videos. I'm just going to exit out of here. And I'll actually show you guys another example with a image, just so you can get more feel for it. So I'll just change it. So like I said, you're going to change this back to test. Keep these. You don't need the external output. You actually can do it for images if you want. It'll just give you the bounding boxes and stuff like that, which is cool. And then, so I'm going to point this at one that you guys will have. This is the one that comes with it when you download it. Data horses.jpg. Oh, there, I see an error there. Can't have two of those $signs. And I need to do it as /darknet.exe. There we go. And this will be a picture of a couple horses. Boom. Perfect. So I think that almost wraps up the video, guys. Once again, if you want to learn more commands and how to play around a bit more, you can always go back to the Lexi AB's Darknet video. But thanks again for watching, guys. If you enjoyed the video, feel free to subscribe and like to the video. It'll mean a lot to me. And comment down below what videos you guys want to see. If you want to see more YOLOv3 videos, maybe custom detection, how to annotate your training images, any sorts of stuff, just let me know in the comments below. Thanks, guys.